Just like a.
Oh.
Something we don't know
And I don't know what I
I
know.
Okay, we're gonna go over the homework and then we're gonna do some drills because we need them. Anyway, number 4, this is a typical problem on the period clock. So we got, what is it? 1, 2, 3. And then 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. And then we got quarter circle, another quarter circle, and then a line. Oh, it's supposed to go halfway in between there. Okay, there you go. This is the graph of f. G of x, this one's a little, there's a twist in it. There's the x of f of t dt. Okay, so compute g of -3 and g prime of -3. Also, this is 3 points here, 1 point for each one. So part A, compute g of -3, g prime of x, and g prime of -3. This should be an easy 3 points. Okay, so if you plug in -3 into this, what do you get? 2 times -3 plus the integral from 0 to -3 of f of t dt. So that's, did we have the guidance to change that to -6? Okay, you don't have to do -6. But this one, the smaller number's on the top, so you gotta switch the limits, which means it's gonna negate the value of the integral. Because you don't want to lose the 1 point for that, because this is an easy 1 point right here. Equals, and then how do I compute this? Well, if this is the graph of f, the integral from -3 to 0 is the area of this, and done, what did we get for this area?
9 pi.
Okay, good, so this is 9 pi over 4, it's 1/4 of a circle. So -6 minus 9 pi over 4, did we get that? 1 point? Ka-ching! Okay, second step, you gotta take the derivative of g. So here's g of x. Chung, what's the derivative of this?
2 plus f of x.
Very good. Because to take the derivative of an integral, make sure the lower limit is a constant, yes. Take the x and plug it in, f of x, times 1. Okay, so therefore, g prime of -3, you simply plug in -3 into this, so you get 2 plus f of -3, which is equal to 2 plus. So if this is the graph of f, f of -3 is the y coordinate when x is -3, right there. So what is f of -3? Kavi?
Half, 0.
0. You get 2. So did we get all 3 points? Okay, that's a good start then. Okay, part B is worth 3 points as well. Determine the x coordinate of the point at which g has an absolute maximum on the interval from -4. So whenever they ask you for absolute maximum or minimum, this is where you're going to do the candidate steps. Even though this one, you really don't need to, but we're going to do it anyway. So, first of all, you take the derivative. Here's the derivative right here. And then you got to find out when it's 0, so you can put it on the number line. So here's g prime, I'm just going to write it again, equals 2 plus f of x. When is that equal to 0? When f of x is equal to -2. So here's the graph of f. Where on this graph is the x coordinate -2? So here's -2, right there. So where do they intersect? Right there. Now you can't tell from my drawing, but you can kind of tell from your picture where it is, yeah? Or if you're unsure, because sometimes they try to trick you, sometimes it's like close, but you really can't tell. So how do you get the exact coordinate of that point right there? Okay, you can do slope, or how about, like, what if it's not a line? What if it's like a curve or something? You want to write the equation of this, and then find where it intersects the line y equal -2. I mean, but this one's a line, so it's kind of easy, but it's not always going to be a line, because I've seen problems where it's not a line. What's the best way to write the equation of this line? Y equal, what's the slope of this line? What is rise over run? What is 3 over 1.5? -2x plus, and then the y-intercept up there is 3. So how do you find where it intersects the line y equal -2? Substitute it in, so you get 2x equal 5, x equal 5/2. Now, a lot of you can get that, right, just by like looking at the slope, like you said. But like I said, what if it's not aligned? Then you gotta solve equations. Okay, now we're gonna do the candidates test. So this is the critical point. So how do you do candidates test? We're doing it for G, yeah? Yeah, G. So you put the endpoints. What are the endpoints here? -4 and 3. And then there's only one critical point in there. Okay? So what did we get for this value right here? Burks. Did we actually compute? No, we computed -3, so it doesn't come into play. We gotta do it all over again.
2.25.
You can't use a did you use a calculator again?
No.
Well, why 2.25 then?
Because that's like one of the triangles,
Oh, you mean, what?
right? Because it's integral from
0.25.
0. Oh wait. Oh, never mind.
I think you meant 2.25 pi, huh?
Yes.
Okay,
Oh, wait. 4.25
What's quite high? What is this 4.25 business?
plus 1.
Okay, look, to compute g of -4, you gotta plug in, okay, look, you gotta go on the side. G of -4 is equal to 2 times -4 plus the integral from 0 to -4 of f of t dt, but then the smaller numbers on the top again, so you gotta switch the limits, -4 to 0 of f of t dt. So,
I got it.
the integral from it's gonna be this, but this one counts negative. Okay, what's this area then? That's 1/4 of a circle of radius 1.
Oh, I was looking at the wrong thing. I was looking for 5/2 instead of -4.
Okay, we're not doing that one.
Oh,
Just tell me what this area is.
okay. 9 pi over 4 plus.
What? No, just that area right there. 1/4 of a circle of radius.
Pi
1.
over 4.
Okay, there you go.
Yeah.
Whoa! So then it's gonna be -8 minus, now what is this integral right here? Well, that's below the x-axis, so it counts negative. And that one is above the x-axis, so it counts positive. And then you can just leave your answer like that, or do you want to simplify?
Nah.
Okay, f of 3, no, g of 3. Okay, what did we get for this one here? G of 3. Who got this one? Harada.
6.
Okay, 6 is correct. And what about 5/2? Kishinami.
I got 4 plus 9/4.
4 plus 9/4 is correct. Okay, so it says find the absolute maximum. Which of these numbers is the biggest? Oh boy. Is this bigger than 6?
Yes.
Yes. There you go. So now let's answer the question. So this is like, I guess you should write absolute maximum. So answer the question. Determine the x coordinate at where you have the absolute value. So I guess you could say absolute maximum at x equals 5/2. Anyway, after school today, we're going to candidates test. We got to make sure we're good at the candidates test. Part C, find all values of x where the graph of g has a point of inflection. So what we got to do is we got to make a number line for the second derivative. So where's the first derivative? Right here. Here's the first derivative. So the second derivative is, what's the derivative of 2? 0. The derivative of f of x is f prime of x. So if we're going to make a number line for this, what? If this is the graph of f, we've got to make a number line for the slope of this graph. So where on this graph is the slope either 0 or doesn't exist? Well, first of all, let's look at 0. Is there any place where the slope is 0? No. Yeah, but it says between -4, 4, and 3. Yeah? It doesn't include -4 and 3, so we don't have to worry about that. No. Is there other places where the slope doesn't exist?
Yes.
Yeah, right here at -3, because it's like vertical, right? Vertical, slope of a vertical line is undefined. And then right there we have a sharp point. So -3 and 0 should go on the number line. Okay, so the slope, if the graph is going uphill, the slope is positive. Over here, the graph is going uphill, the slope is positive. The graph is coming downhill, the slope is negative. So it's concave up, concave down. I forgot the question. Find the values of x where it has a point of inflection. So there's a point of inflection at x equal 0 because, what's the reason that I should write here, Braxton Lee?
F prime equals G double prime changes sign.
There you go. G double prime, which is equal to F prime, changes sign. Because remember, this kind of problem where you got like two different functions, you gotta get both of them. Okay, and then the last one is only worth 2 points. Find the average rate of change from here to here. So what's the formula for average rate of change? F of B minus F of A all over B minus A. But you actually got to compute this, so what did you actually get for this? Done? What did this come out to? Negative 2/7, that's good. Okay. There is no point between -4 and 3 where F prime of C is equal to the average rate of change. How come? Because the mean value theorem says there should be one, right? Explain why the statement does not contradict the mean value theorem. So this is why you gotta know, Berks. In order to apply the mean value theorem, the function has to be
Continuous.
differentiable.
Yeah, that's why I wrote, but I said continuous.
Yeah, but,
Yeah.
okay, so Berks, practice. What would you say then?
Because F is not differentiable,
Okay, good.
it does not
F is not differentiable.
This does not.
And if you want to be even more exact, you could say at x equal -3 and 0, right? Because over here, there's a vertical tangent, which the slope of a vertical line is undefined, and then the sharp point there. But I'm pretty sure if you just wrote that, you would get full credit. Or maybe you should be not differentiable at all points. And what is the interval they're talking about? From -4 to 3 or something like that. Just to be even more correct. Huh?
For C,
Mhm.
what if with a number line you just put 0? Like you didn't put -3? Because don't you graph where the slope
Yeah,
is?
I think, I'll tell you the truth, they don't even look at your number line.
Oh, okay.
They're looking for this as a reason.
Oh,
So yeah, you would be fine if that happened. Okay. Let's get rid of this. Yeah. Okay, next page should have been easy. This is the area volume problem, but you guys are kind of scaring me on the final exam when you had these area volume problems. I'm still kind of scared, actually. 9, 6. This is the graph of y equal 2 root x. This is y equals 6, and the y-axis. A, find the area of this region here. Okay, what integral did we get? You're on the,
to go from 0 to 9 of 6 minus 2 root x dx.
okay, good. Everybody wrote that? Top minus bottom? Ring. Okay, now you gotta actually compute this, so you need antiderivative, yeah? What's the antiderivative of this? Harada?
6x minus 4 thirds x to 3 halves.
Yep, that looks correct, from 0 to 9. Plug in the top number, 6 times 9, or we're gonna write 54. I think we better write 6 times 9 minus 4 thirds times 9 to the 3 halves minus 0, and that's full credit. Or do you have the ganas? I simplified it to 18, because I had the ganas. Did you? Okay, good. Just leave this right there. You don't even have to go 9 to the 3 halves is 27, you know. That's full credit right there.
What if you don't put 0 next?
You don't have to.
Oh, okay.
Come on, 0 is 0, that's right, right? You can simplify as much or as little as you want. Okay, revolve this about the line y equals 7, that's up here. Y equals 7. Get rid of this, let's see. So if you draw in the rectangle, see how it's not touching the axis of rotation? You're going to get a washer. So if you don't use a washer in this part of the problem, you get 0. Automatic 0. You have to have a washer equation. What's the formula for the washer? Pi Big R squared minus small r squared dx. Okay, what is big R? Kubikali. Big R.
7 minus 2x.
There you go, top minus bottom. Small r, what is this? Kishinami.
1.
Ooh, you have to got us. Or you can just put top minus bottom, 7 minus 6. And then add them up from 0 to 9, 3 out of 3 points right there. You don't even have to compute that integral. And then the last one is 3. I hope you guys read it because on the final exam you guys didn't read. See how they don't underline it? It says cross sections perpendicular to the y-axis. You guys better underline that word. So let's get rid of this thing. So perpendicular to the y-axis, so you gotta make horizontal rectangle, which means you have to solve for x in this equation. How do you solve for x in this equation? Let's do it step by step. Radical x equal y over 2. So x equals y over 2 squared. Or if you want to go y squared over 4, same thing. Doesn't matter. Okay? So cross section is a square. The side of the square is lying right on the rectangle. What is the length of the rectangle? Right minus left. So it would be y squared over 4 minus 0. And then if you know the side of a square, how do you figure out its area? You square it. But then it has a thickness to it. Did you guys write the dy? Huh?
It's not a square,
It's not a square.
it's a rectangle.
Oh, so now, okay. It's a rectangle whose height is 3 times, so this would be 3y squared over 4. Thanks for telling me. Oh, but it doesn't change the formula, it's going to be 3 times that then, right? Add them up from 0 to 6. Did you guys put 0 to 6? Do not put 0 to 9 because you're doing the integral in terms of y. So we got 9 out of 9?
Yeah.
Alright, that's good. And there were some little tricky things in this next one here. But not that tricky. 4 pi. So wonk, wonk. This is the graph of G. Okay, part A. Compute the integral from negative 2 pi to 4 pi of f of x dx. But they told you that f of x is equal to, where is it? G of x minus cosine of x over 2. So what's the first thing that you did, Chung?
I split it up.
Split it up into separate integrals. So integral from negative 2 to 4 pi of g of x dx minus the integral from negative 2 pi to 4 pi of cosine x over 2 dx. Everybody did that? Okay? And this is the graph of g up there. So, if this is the graph of g, what does the integral from negative 2 pi to 4 pi tell you? It tells you this area right there, right? Hey, that's just a triangle. So you just go 1/2 base times height. And just leave it. Minus, now to compute this integral, we got to do antiderivative. What's the antiderivative of cosine x over 2, Braxton Lee?
2 sine x over 2.
Okay, good. From negative 2 pi to 4 pi, factor out the constant. Okay, I'm just going to do the computation over here. So 2 times, plug in the top number, 0. Plug in the bottom number, 0. That's just 0. So the answer is, do you want to simplify this to 6 pi squared? Yeah, no ganas, no ganas. Just do this, minus 0. Think that would be good. Okay, how many points was that worth? How come I don't have it written here? It's 2. It was only 2 points. Oh, that's because part B is worth 4 points. Part B, find all values of x in the open interval for which f has a critical point. That means when the derivative is equal to 0. Okay, now this one takes quite a bit of work. So, first of all, what are we looking for? F has a critical point. So, f of x is equal to g of x minus cosine x over 2. So what is the derivative? What's the derivative of this? G prime of x. And what's the derivative of the second term done?
Half sine x
Plus 1/2 or minus?
plus
Plus 1/2.
sine x over
Okay, that is correct. That's correct. Okay, now we gotta find out, it says, for which f has a critical point. In other words, when is the derivative equal to 0 or doesn't exist, right? But there's a problem here. Look, g of x, it's a piecewise function. So what you need to do is you need to write the equation of this line and this line. You gotta make like two separate cases. Is that what you guys did? No. Okay, that's what you gotta do if you're gonna get points here. So what's the equation of this line? Y equals,
X plus,
okay, the slope is 1, so x plus, and the y-intercept is 2 pi. And then what about this line? Y equals, what's the slope?
negative half.
Negative 1/2 x plus 2 pi, right? Because the y-intercept is 2 pi. Okay, so we gotta make two cases. One goes from negative 2 pi to 0, and the other one goes from 0 to 4 pi. Okay, so from negative 2 pi to 0, what is the derivative? G prime of x. Now, if this is g, what's the derivative of that? 1 plus 0. 1 plus 1/2 sine x over 2. Now, from 0 to 4 pi, then the derivative is going to equal g prime of x. Okay, but this is g. What's the derivative of this? Negative half. Well, I guess, yeah, you didn't have to write the equation of the line since it was a line, right? Because the derivative is simply the slope. But what if it's not a line? And then, of course, plus 1/2 sine x over 2. Okay, so when will this equal 0? When would 1 plus 1/2 sine x over 2 be equal to 0? Well, when 1/2 sine x over 2 is equal to negative 1. When sine of x over 2 is equal to negative 2, impossible! No can. How come sine x over 2 can't equal negative 2?
It's not in the range.
Exactly, because sine always is between negative 1 and 1. How can sine ever be negative 2 when the smallest it ever gets is negative 1? So no can. Now what about on this side? When will the derivative be equal to 0? Well, when this is equal to half, divide by a half, when sine x over 2 equals 1, therefore x over 2 gotta equal? Sine of what angle is 1?
Pi. Or pi.
Pi over 2. And then also, I guess you have to consider 5 pi over 2, right? If you go one more time around. Because when you multiply both sides by 2, you're going to get pi and 5 pi. But 5 pi is bigger than 4 pi, so no, we don't need that. So it's only pi. So that's, okay, so if you did this, you would get 3 out of 4 points. Mr. Park, how can I get all 4 out of all 4 points? What did we not consider?
0 point.
Right there, what about when x is 0? Well, what? When x is 0. Look, you have to actually say this on your paper. When x is 0, yeah, g is not differentiable there because you have a sharp point. So therefore, when you take the derivative of g, where's the derivative of g? Right there. Yeah, doesn't exist at 0 because there's a sharp point. So you actually say that on your paper, otherwise no one can get all the points. And then finally, oh, that was only part A.
Wait, can you say that again?
Okay, because to figure out what f prime is, you gotta compute g prime, right? But if this is the graph of g, the derivative doesn't exist at 0 because you have a sharp point, that's why. So you have to say at x equals 0, f prime does not exist because g prime does not exist.
Wait, who's going to explain?
I don't know, but I looked it up on the thing and they said you have to consider the x equals 0 point separately.
Wait, why did you get 0?
Because,
You stuff.
because right here is a sharp point.
But then didn't you isn't that?
Oh, that's because the left part of the graph and the right part of the graph, that's where they actually meet, that's why, right? That's
Oh,
why,
so you didn't consider the 0.
no, we can't, right, because, again, in sharp point, right?
Yeah,
The
so
derivative doesn't exist.
you have to consider the 0 because you didn't.
Yeah, well,
consider
yeah, you have
the-
to say it on your paper, the f is not differentiable at x equals 0.
because of.
And you can just say because of sharp point. Just say sharp, remember what that came up before? Just say sharp point. That's the easiest thing to do. Anyway, that's what it said on the, whatever, what did they call it? Scoring guideline. Okay, part B. Oh, we just did that. Okay, part C. Oh, we better get this one. Unless your name is Roy Song. Compute h prime of negative. Okay, so first we gotta compute h prime of x. Okay, how do I take the derivative of this thing? Whose turn is it? Kishinami. How do I take the derivative of this?
G of 3x times 3.
Yeah! Don't forget to multiply by the derivative of that. That's the key now. If you do not multiply by the derivative of that, you get 0 on this problem. You need that 3 there. Okay? And then what? What are we trying? Oh, then all you gotta do is plug in negative pi over 3. So what happens if I plug in negative pi over 3 there? Really? You get negative pi times 3. So all we have to do now is compute g of negative pi. Well, this is the graph of g here. G of negative pi would be right here. What is the y coordinate right there? Pi. Yeah, just see, if you wrote the equation like you're supposed to, just plug it in. If you plug in negative pi there, negative pi plus 2 pi is pi. So pi times 3. Boom! Just leave it like that. That was 2 points, but like I said, if you didn't multiply by 3, you get 0 out of 2 already. All right. Why, was that a harder one? Not really, yeah. Not really hard. Okay, let me turn this thing on.
I got the first one.